Hi everyone, can you hear me? Okay, I think I'm audible. So now let's start. Let's just continue with our topic, which is forwarding of a IP packet. So let me open up the slides, right? Okay. Now suppose that there is some packet that is coming to this router, and let's suppose that packet is having some IP destination IP, which is saying that my destination IP address is 180.70.65.192, right? Let's suppose this is what packet is saying. And this router is connected to different IP addresses. So it is connected to, different networks, which is having some different IP addresses. So it is connected to this network, this network, this network, this network. So 4 networks that it is connected to. And if let's suppose if this is the IP address that it is saying that this is the IP address of the packet that is coming to it, then let's see that where does this router forward this packet. So my question is that suppose there is a packet that is coming to this router with the IP address, which is this one, which is 180. So let me just write that again, maybe 180.70.65.192, 180.65.70.65.192. Okay. Now the packet is just containing the packet that is coming to this router. It is just containing few things, but one of the things is just destination IP address. Does this packet contain that is coming to this router? Does this packet contain any slash, which means slash 20 or something? No, right? Which means this packet does not contain any subnet mask. Subnet mask is this router have the subnet mask. It has to calculate that where to forward this packet. Okay. So now suppose this packet is coming to this router and this router has to make a decision that where to forward this packet. Now let's just check. What do you think where we should be forwarding? Let's suppose this is the network A, this is the network B, right? Then should we forward to network A or network B? That's what we need to decide. Network, let's suppose this is C and D or P and Q. So this P and Q are not designed for this particular IP address, obviously, because this is 180.70.65.192 and these are some others, right? So maybe this IP address belongs to this network, or maybe this IP address belongs to this network. That's what we need to decide. Then what do you think? Maybe from this, it is very clear that this IP address, this is 65.192. This IP address belongs to this network, which is network B, right? So this router will send this this particular packet, and which is maybe belonging to this. So this will send this particular packet to this particular network. Let's suppose, for example, this is 193, 195, something like this. Let's suppose it is 195. Okay. Now this particular address belongs to this particular this particular network. So this router will send to this network. Like as a human, you know this, but how does this router calculate that where to send this? So for this, it has something called as routing table, right? So this router, let's suppose this name is R1. This R1 is having routing table, and R1 routing table looks something like this, where it will say, let me go to the next page. It will say whatever is the network ID, whatever is the prefix, and whatever is the interface, which means if this is the network ID, then this is the prefix and this is the interface, which means that I will send any network, any particular packet with this network ID to M0, if this is the network ID and this is prefix, which is 25. So it will be having some fields, which will be having some network ID 180.75. .65.128, right? And then /25, which is your network prefix. So it will say if this is the network ID and if this is the network prefix, then I will send that to interface number M0. So that's what router has, in its routing table. Now what it will do, it will take this IP address, it will apply this mask 25. So if you apply this mask 25, which means these are the 24 bits. If you apply the mask which is 25, then it will be 128, right? Okay. Yeah, for this router, it will be 128.65.128. If you apply the mask, which is /25. Okay. So let's do one thing. This will be 128, and then just a second. Yeah, just for the sake of example, just for now, I will come to the point that it is written here. Just for now, suppose that this particular network is not there. Suppose, okay. I mean, just for the sake of this example, suppose this is not there, and you just type this, which means this is the network ID and something like this. Now, if something is coming with the packet, maybe I'm saying 180.70.65.192, right? Something like this, .192. Then it will do what? It will take this destination IP address, and then it will make this as a mask. So if it will apply this mask, so what will the output if you apply the mask /25? What will the network ID? It will say initial 25 bits are fixed. So 192 means 11 and all zeros. So if initial 25 bits are fixed, then you will be having 180.70.65.128. So that's how the router gets the network ID. So this is the destination IP that router will receive. It will apply this mask. It will check, okay, if I apply this mask, if I'm getting this network ID, then I will send to M node. Am I getting this network ID? If the answer is yes, I will send to M node. That's how this router is working, right? So let me just show you. So see here, if this destination is coming, now it will apply this prefix mask, and based on that, it will take a call, right? So this is the IP address that I'm receiving. Now this is the destination IP. Okay, I will apply this network, and if the network ID is same, then I will forward that to particular interface. If that is not same, I will do that with again with another prefix. So which means I will apply this IP1. This network was N1 to IP1. If N1 and IP1 is not giving me A, then N2 and IP1 may give me B, or otherwise N3 and IP1 can give me C, something like this. So basically, I will keep on applying this prefix match, and I will be saying that to which network it belongs to. Based on that, I will take a decision, right? Okay. So suppose that this is coming, and then based on this, I will take a decision that it should go to M node, M3, something like this. Okay. Now, let's consider a scenario where you are having two routers, R1 and R2. Now, in this, okay, just a second, let me check what is written. Yeah. So, in this R2, it will be having its own routing table, right? Let me just go to this slide. So here, let's consider this scenario. So here, R2 will be having its own routing table, and R1 will be having its own routing table, right? So there are two routing tables. One is for R1, one is for R2, right? Now, what are the fields in the routing table? One of the field is called a network ID, like which network ID and prefix. These are the two important fields, and third field is interface, like which interface I should send to, something like this, right? Now, let's suppose that this is the routing table for R2, where I'm saying that if this is the network ID and if mask is 26, then I will send to, okay, this is the routing table for R1. If this is the network ID, if mask is 26, okay, if mask is 26, I will send to M node. So I will send to M node, otherwise M1, M2, M3, something like this. So this is the routing table for R1. Now suppose there is some particular IP address, anything, okay, which is coming to this R1. Let's suppose there is some particular IP address or some particular packet which is coming, which is having some IP address. Let's suppose it is 140.24.7. Let's suppose it is 50, right? Okay, 50 will be in this because till 0 to 63 are in this. So let's suppose this is the destination IP address that I am having. Now this router one will be doing what? It will be checking that which network it belongs to, right? How it will be checking? Based on its routing table. Now decide that, okay, it belongs to M node, so it will send to M node. That's how it works, right? Okay. Now this is the routing table for R1, and based on this routing table, we will take the decision. See, this is the routing table for R1. So I will do what? If some packet or something like this is coming, Okay. So suppose something like this is coming, then based on this routing table, we will take the decision. Now, can you tell me how I'm going to take the decision? I will apply the mask. I will apply this 26. If you apply the mask 26 to this, you will be getting the network ID, which is 140.24.7.0. If you're getting the network ID which is matching, then you will be basically saying that, okay, it belongs to interface M0. So it will send to the interface M0. So there is one doubt. So we'll do end of the IP addresses of the packet with a mask. Yes, it will do the end. Apply the mask means it will do the end operation. And then it will get the network ID. If the network ID is same as this, then it will forward that IP that packet to this particular interface. That's how it works, right? Okay. But now suppose that it is matching to multiple, which means let me go to this particular example. Okay. So suppose yeah. So suppose that this is the table for this router R1, and there is some IP address which is, let me just take this, okay, and let me just give you the example. There is some IP address which is basically matching to multiple. Then how it will take the decision? Suppose that IP address is this one is the same IP address. Okay, if you apply 26, then what it will give? This 192 is basically two ones, right? 128 and then 64, two ones and all zeros. If you apply 26, this is 24, 25, 26, then it will this 128. Okay, the IP address that is coming, let's suppose, is maybe 193 or something like this, right? Let's suppose it is 193 that is coming to it. Then if you apply this 26, then what it will give? If you apply 26, then will not it give 192? It will give 192, right? Because 192, like this, if you apply the 26 here, then this 193 is basically 1, 1, 1, 2, 3, 4, 5, and then 1, right? If you apply 26, then it will say that, okay, everything else is 0. Then it will convert this to a network ID, which is something like this, 192, right? If you apply 26, you will be getting this network ID. So it should send to interface M0. Is this okay to everyone? Let me know if there is any doubt. So basically what is happening here, that if you are applying this network ID, then it is matching with, you are applying this mask, then it is matching with this network ID. So it should send to this. But if you apply 25 also, right? So here in this particular configuration, let's suppose this is the configuration that I have. And here, if you apply either 25 or 26, you are getting the network ID which is matching, which means even if you apply, let me just show you. So if you apply 26, you will be getting this. If you apply 25 also on this, on the same, then you will be getting the network ID, which is 180.70.65, not 128, right? If you apply 25, then you will be getting 128 because 25 will take just this one. So if you apply 25, you will be getting 128, which is basically matching this. I mean, 25, 128 is this combination. 25, 128 is this combination, which is matching this. If you apply 26, then you will be getting 192. So basically, this particular IP address that this R1 is receiving, okay, this particular IP address that R1 is receiving. So the complete diagram is this. It actually matching with two of the things. Then in this case, where how I should be taking the decision? You're getting my question? So how should I be taking the decision? Based on, so yeah, so this is what I have. If let's suppose I have an IP address which is matching with two network IDs. Yeah, based on the longest prefix. So suppose that this IP address, which is the destination IP address, it is matching with two entries. One is this, another one is this. Then I will go for 26, select 26, longest match, right? Reason being is that this is more specific, right? I mean, this 25, I will tell you in the Supernetting that what do I mean by more specific, but here just understand that I will be, if I'm matching with two entries, then I will be basically going for the longest match. So here, this destination IP address that it is talking about, this since it is matching to two, M2 and M0, so M2 and M0, it is matching to two, but it will forward to M2 only, not to M0, because M2 is longer prefix. So that is why it will forward to M2. So that's how the forwarding works. Yes. Okay. So if there are multiple match, let me just write it. Multiple matches. Okay. So let's just solve few questions based on that. Let's solve this question. So suppose that this is a routing table and they are saying on which interface will the router forward the address destination to this and this. So there are two destinations. Okay. So one of the entry is default entry and it says like if nothing is matching, you can go here. So on which interface it should send? Let's just solve this question. Here, this means let me, instead of writing this in this notation, let me write in the slash notation. Can you quickly convert to the slash notation maybe? Or if you don't want, there is no necessity. So maybe if you want, you can do it. Otherwise, there is no necessity. So let's just work with the first IP address. This IP address, what do you think it should belong to? This is saying these bits are fixed. So this is matching to this, definitely, right? This IP address is matching to this entry because if you apply the mask, which is all these bits are fixed and you can just make them 0. If you apply the mask, which is the first one, right, it will be basically this one. Okay, which means it should go to Ethernet 0. Or maybe if you apply the mask, which is first, which is, I mean, in the last octet, the first bit is 1. If you apply that mask also, then it is also matching. Right? If you apply this mask, so it is saying Ethernet 1. So what do you think I should be using? So I have just matched with two masks. If I'm not matching with anyone, then I will go for default one. If I'm matching with at least one, I will go for that. If I'm matching with two, then I will go for the mask which is having the longest mask. So which one is longer? This one or this one? Ethernet one is longer, right? So since Ethernet one is longer, so I will go for the Ethernet one. So either A or D is the answer. So for this one, let's just check. For this one, you will say which one is longer. Okay, here it is saying that, okay, yeah, this is interesting. Can anyone tell me? So it is saying, this mask is saying that it has to be, it is just having one address. It has to be this 192.12.17.1 or 17.5 only. There should not be any change, but it is 10. So it will not match with anyone. Since it is not matching with anyone, it will go for the default one. So that's why it's 102, right? So since it is not matching with anyone, it will go for the default one, which is 102. So that's why A is the correct answer. Okay. Let me know if that is clear. Okay. So how to choose between 0 and 1? Okay, since it is matching with 2, it is matching with 2. This address, if you apply the mask, this one or this one, it is matching with this also, it is matching with this also. Then in that case, I will go for the destination address, or I will go for the network which is having the longest match, which means number of ones should be more. So here the number of ones are 24. Here the number of ones are 25. Right? So I will go for the number of ones which are having 25 ones. Why that is the case, that you will understand in the Supernetting, like why I am preferring this. Okay, so why I will clear in the Supernetting in just 10 minutes, 15 minutes. So first you should understand that this is the rule that we are going to apply, that we are going to send to the longest mark. Why we are sending that, it will clear. Okay, now probably let's solve more questions. So an IP router implementation, classless is also called CIDR, classless interdomain routing, CIDR, receives a packet with IP address this. Okay, so can you tell me which IP it should belong to, which interface it should go to? So this is saying 12 bits are only changeable. So the 12 bits are only fixed. It is saying 14, 16, and 15. So here, does this match to this 15? Okay, maybe let me just check with the longest one first. Okay, let me just check with the longest one first. Because if I check with the maybe smallest one, then maybe I have to check more. Then let me check with the longest one. Does this match to the longest one? If it is matching to the longest one, should I check with others also? May not be, right? So, okay, let me just check. Can you tell me, is it matching with the longest one? This is 16. So it should be 131.19. It should be fixed. But here 131.23. So that's why it is not matching with 16. Now let me check with the other longer one, which means this one. So let's just check whether it is matching with this one. So it is saying 15 bits are fixed, which is 131.22. Here the 15 bits are fixed, and then you can change all of them. So here let me just apply /15, right? Now it will be 131.23. Okay, I think it will match, because here in the 23, last bit will be 1. Whatever is the number of bits here, okay? So those same bits will be here, but the last bit will be 0. You getting my point? So in 23 and 22, what is the difference? The difference is only in the last bit. Okay, if I do not represent the whole number as a binary, then also I know the difference is in the just last bit. In the 23 and 23, at least I know, right? I mean, whatever the 0 and 1s are there, but the difference will be, it will be 1, it will be 0. Then I can say that if you apply /15 here, then it will be same as whatever here, like till this point, which means like it will be basically 22 only. .0.0. I mean, you can convert that to binary and you can apply, but it will be 22 only. So basically, I can say if you apply /15 here, yeah, you can convert that to, if you want me to write, then I can write 23 will be, see, this 23 will be 10111, right? And then 1 2 3 4 5 6 7. Okay, so this is 23. Now what is 22? 22 is basically 0 0 0 1 0 0 0 1 1 0, right? So if you apply this mask /15, so basically you will be keeping all these bits are same. So which means that you will make all of them a 0. So which means that this will be 22 only, right? This will be 22 only. So basically, like, I hope it is okay to everyone. Let me know if there is any doubt. Basically, if you just apply this /15, then whatever you are getting is just 22. You will be getting 0 0 0 1, then 0 triple 1. These bits are fixed because of /15, and then you can take everything else as 0, right? So which is just a network ID which is given to me. So it is actually matching with this one. These two are same, right? These two are same. So that's why you will say that it is matching with this one. So answer should be 1, right? So here the answer is 1. And you should be checking with 14? I don't think so, right? I mean, if it is matching with the longest one, you should stop at that point only. You do not need to check with 14 or 12 or something, right? It I don't know, maybe it can match with 16 or may not be, but you do not need to check. Okay, so let's solve this question. Now this is the network mask. So what is the answer here? Yeah, answer is interface 1, right? Okay, so see, it is matching with interface 3 and interface 1 also, but we need to take the longer one, right? Or anyway, if you're going in the decreasing order, then generally we do not need to take the longer one. So tell me, what do you think practically it should be implemented? I mean, practically, do you think that routing table will be something like this? Or maybe you think that it should be like whatever is the highest one should be at the above, so that I can, like, router can keep on checking from the above. The moment it finds, it should stop, right? Yeah, it should be ordered. Yes, that is correct. So practically, if two networks are having the same prefix or something, then the longer marks will automatically be above, so that we reduce the multiple, scanning the whole routing table. Otherwise, we need to check the whole routing table always. So that's not a good idea, right? Similarly, can you tell me practically this default should be what? I mean, here I'm just writing default. Default means like if the router match with this, then it should match. So basically, I can say this default entry could be something like this, right? And the mask could be 0. So if I apply, like let's suppose this is 0.0010, this is 0.0000, right? This is subnet mask. So if I apply to any IP address, if I apply this mask, will not we be getting this IP address to any IP address? Okay. 32.35.192.27. You apply this mask of 0, which means nothing is fixed. You change everything at 0. You can change everything. So will you not be getting this? So basically default means, like practically, I mean, in terms of implementation, I can just write 0.0.0.0 and here I can write subnet mask at 0, right? Default means this. Okay. Now you understood very important point, which is what, like if it is matching with multiple entries, then we will go for the longer one. Why we are going for the longer one? It will be more clear. Okay, don't worry. Now let's solve this question. Consider the following routing table at IP router. And it is the routing table. For each IP address in the group, identify the correct choice of the next hop from the group 2. Okay, so if this is the IP address, then it should go for which one? That's what they are asking. Okay, if this is the IP address, then can you first find out the slash here? It is /8 and it's 16 and then this is just 23, right? 23, sorry, this is 24. No, sorry, this is 23, this is 23, this is also 23, this is 23, and this is I think 22, right? Okay. Okay, so let's apply this 128.96.171.92. Let's apply this /23 here. 23. If you apply /23, will you not be getting 170? Because 170 and 171 are differing just from the last bit, right? I mean, 170 and 171 are just, +1 equal to this. So basically they are just differing in the last bit. So that's why if you apply just 23/23 here, then you should be getting this one. So which is 128.196.170.0, right? If you apply /23 here. Okay. So should I be checking with other entries? Let me just think about it. See, these are same prefix match, right? This 23, and this is 22, and this is even smaller. So I should not be checking. I don't think there is any point in checking, right? So that is why this is final. I mean, it is matching with one of the entry. So here I will say it should go to interface 0. So one should match with A. So either A is answer or B is answer. I hope you can see options, right? So either A is answer or B is answer. Let's just check with other also. Let's just confirm with the second one. Okay. So second is saying 128.96.167.151. Okay, let's apply 23. If we apply 23, then I don't think it will be 170, because only on 171 and 170 it will be 170, right? Otherwise it will be something else, because 167 will be differing in other bits. So it cannot be 170. Can it be say 168 if you apply 23? So if you add 1 here, then it will be 168. Yeah. So let's just check if this 168 and if we apply /23, then can it be what it will be? Basically, that's my question. Okay, it should be 166, not 168, right? Because if you apply 23, then this bit, the last bit, since it is odd number, last bit is 1, definitely 1. If you apply 23, the last bit will 0, nothing else will change basically, right? Only the last bit will change. If you apply /23 in this number, only the last bit, which is 1, it will change to 0. So basically it must be, if you apply 23, it must be this one, 166 only. So which means that it is R2, right? If you apply 23, then this is R2. Okay. So I think for this, it is matching R2, right? So yeah, it is C. So I think A is the correct answer, right? Now you can check with these two also. Let me quickly check. 128.96.63. Let me remove these. Okay. So it is 128.96.163.151. Now, if you apply, so it is 23, 22 only. So it should be, by the way, it should be E answer default. But anyway, let me just check. So see, if you apply 23 here, it will be just 162, right? Slash 23 will give you 162 only. Slash 22, can it give you 164? See, you are going to make the last bits of 0. I mean, you are going to decrease the number anyway, right? Okay, can you mute everyone? Yeah. So you are anyway going to decrease the number. That's why it will be default entry, right? So 163, if you apply the 23, 22 something, it cannot increase the number. There are increased number 170, 168 like that, right? So it will be just decreasing the number. So that's why it will be the default entry. Okay, see here 0.0.0 they have actually written this, right? So anyway, it will be R4. So that's why it is E. And if you check this, now if you apply, I think again, this is matching. Okay, this is, if you apply maybe 23 or something, it cannot increase the number. So that's why these things will never match. It cannot increase the number because you are going to make something as 0, right? So it cannot increase this say 164. That's why these all will never match. It may match with this last one, R3. So let's just check if you apply 22 here. So probably if you apply 22, which means last two bits. Okay, if last two bits of 164 are actually 0, then it can match basically. Right? So you can check. I think last two bits are 0 because it is divisible by 4. So that's why last two bits are 0. So anyway, it is divisible by 4. That's why the last two bits of this particular bit will be a particular number will be 0. So that's why it is actually matching with this one, right? So anyway, so it is matching with this one. So that's why R3. So let's do this question. Can you do this question as a homework? Okay, this is easy question. You can do as a homework. Now, let's just do address aggregation or the supernetting. Okay. Suppose that there are few networks that I want to combine. So these are the few networks and I want to combine these networks into just one network. Then what does it mean to say that I want to combine and all? Let's just see this, okay, from the slides. Suppose that that I'm interested in writing the routing table for R2. Okay. Then can you tell me how does the routing table for R2 look like? Routing table for R2. Okay, this is the routing table for R1, which will say that, okay, slash 26 like that, M0, M1, M2 like that it will say. But routing table for R2 will say, maybe it is something like this. Okay, slash 26, then also it has to send to M0 only. Maybe if it is belonging to this network, slash 26, this network, then M0 also, then on M0, it means it is writing 4 times M0. And by default, it is writing M1. Let's suppose this is the case that I have, right, for the R2. Is there any problem in this routing table? Can anyone tell me if there is any problem in this routing table? Will this work or will this not work? Yeah. So basically, there is no problem as such, which means that it will work, but it is basically having many entries unnecessarily. So what you can do is basically something like this. Just a second. Yeah. So suppose this is the table that you have, and this is the routing table that you are having, right? Then what you can do, you can basically say that you do not need to maintain all of these entries. How? Let me just tell you. So first of all, Are you all good with the thing that this routing table of R2 will look something like this? Yes. Okay. Now I'm saying that, okay, if it is starting with like, I mean, if it is this network, then go to M2, M0 or something like this. Now instead of having these four entries, can I just have one entry here? Tell me. Can I just say that instead of the four entries for R2, I will be having just one entry where I will say probably one is, I mean, default entry is already always there, and one entry will be, I will say, if starting with 140, starting with 140/8, then go to M0, right? If it's starting with 140, I think instead of these four entries, I can just work with one entry. Okay, so that's a good idea, but generally we want to be very specific. Okay, which means instead of saying that we should start with 140, can I say that if it is starting with not just 140, if it is starting with 140.24, then I will send to M0, right? If it is starting with 140.24, then I will send to M0. Can I say something like this? I think I can say, right? So I can say that, okay, if it is starting with 140.24, then I will say anyway, I was sending to M0 for all of this check. Instead of saying like this, I can say that maybe it, like earlier I said, if it is starting with 140, then I will send to M0. But now I'm just being bit more specific, not just 140.24 also, right? Then I will say that I will send to M0. Can I be a bit more specific? Yes, I can say if it is starting with 140.24.7, then I will send to M0. Then can I be a bit more specific? Let's just check if I can be more specific, which means let's just check that how many bits are common basically. So I will say that, okay, let me just write these four networks in the binary format. Then I will say that, okay, till this point it is common. So I will do one thing, till whatever point it is common, I will take that common part, and based on that, I will like immediately calculate the this number, this subnet mask, which is basically 24, because these bits I want to be fixed. So I will say that, okay, whatever is common, I will be having just one entry till whatever point it is common, and I can be more, best I can be specific till this point, right? I mean, I can say 140.24. That's also work. Maybe 140 also works. Even what is the worst specific thing that I can have? Can anyone tell me? Maybe I can just say if it is starting with maybe anything, right? I mean, just I will take just some part of this 140, something like this. So basically, if I want to be very, very, very specific, then I will just go till the point till the everything is same. So I will go till 7. Can I go beyond 7? No, because now bits are changing, right? That's why I cannot go beyond 7. So I will, instead of these four entries, right? Once you understand how forwarding works, then you will understand this. So instead of these four entries, I will be having just one entry, which will say something like this, which will be saying 0, and then this will be till, I think, 24, right? Till 24. So this is the idea behind supernetting. Supernetting is basically just a logical aggregation. So basically, I'm just aggregating. I'm just aggregating at this router perspective. So tell me, for this router, what is the routing table? This is the routing table. But does this router has the same routing table? No, right? I mean, this router has to go to either M0, M1 or something like this. So this routing table will still be a longer one, because it has to say that, okay, either go to M0, M1, M2, M3. It cannot say just go to M0 if it is starting with 140 or something like this, right? So R1 is still having a longer entries, I mean the many entries, but R2 can shorten their entries, right? So I hope you got it, like how we are sorting out the entries. Okay, now let's see more examples. So here this R2 will be saying, yeah, R2 will be saying that this is my routing table now. Okay, forwarding table or the routing table, I mean these terms are commonly used, forwarding or routing. There is no specific difference, but I mean, or like some author just uses this routing and forwarding as interchangeably, but a very specific difference is this. Routing is basically deciding, I mean, if I'm using, okay, I'm doing the masking and all, so routing is basically an algorithm that decide, okay, or deciding which interface to which interface phase to go on. Okay. Forwarding is actually forwarding it. It's a process. Okay. It's a process. Something like this. Process. I mean, which actually forwarded. Forwarding is basically just a forwarding. I mean, just a term. Like let me just write. It does not decide anything. Once decision is done, then we are forwarding. Something like this, right? So let me write in this way. Once decision is done, okay. Anyway, these terms are not much important. But if you are being very specific, then routing is basically an algorithm which decide that which interface to go, and forwarding is actually just a process of forwarding. I mean, once the decision is done, then you are forwarding, something like this. So the routing table for R2 will look like this, and the routing table for R1 will still be looking like some bigger one, something like this. Okay, whatever we had earlier, routing table for R1 is this, right? So that's the difference between the routing tables of R1 and R2. Now, this is the routing table for R2, and let me also write the routing table for R1. This is the routing table or the forwarding table for the R1. Okay. So R1 is still having many entries, but R2 can have lesser entries. Cool. So now let's go to this one. So what you will do, if you want to aggregate the network, then what you will do, you write that addresses in binary so that you can see that what is best common. Okay. I mean, if you want to merge all of this with respect to some router, okay, this is always with respect to some router. It is just to help routers. If you want to merge all of this, then what you will do, you will say, okay, till this point is common, then you will be doing something like this, right? Cool. Suppose you want to merge these three networks, then what you will do, you will again write that in this form. Then it is just common till this point. See here, till this first bit it is common, till this first byte it is common. So you will be writing something like this. Now, now let's just see one interesting point, which is this. See, let me take this example. Let me explain you one very interesting point, which is also a misconception to many of the students. So let me tell you. Suppose that you are having these networks. Now tell me, initially, if you are having this, then how many IP addresses are there in this? Maybe you will say 2 power. How many bits you can change? 23, right? 2 power 23. 2 power 23 IP addresses are here. How many IP addresses are here? Again 2 power 23. How many IP addresses are here? Maybe 2 power 22, right? So the total IP addresses that I had earlier before supernetting or before aggregation. So the total IP addresses were 2 power 23 plus 2 power 23 plus 2 power 22, right? This is number of IP addresses. Number of IP addresses before aggregation. Now, after aggregation, let's just see how many IP addresses I have. So basically, I'm saying this is just one entry. So how many IP addresses are there? This is 2 power 22, right? Sorry, 24. 2 power 24 IP addresses, right? So which means it is, let me do one thing. Let me rewrite this 2 power 24 just like this, okay? 2 power 23 and 2 power 23. I mean, I'm just rewriting it. If you add these two, this is 2 into 2 power 23, which is 2 power 24. I'm just rewriting, okay? Similarly, okay, just a second, something wrong here, right? This is 23. This is also 23. This is 22. Okay, this network, actually the example that I wanted to show is something else. So this network is actually just redundant, I think. I mean, this network is actually maybe in one of this network. Okay, maybe in this network only. So, okay, the example I wanted to show you was something different, but this actually does not convey that example. So let me take one example. Okay, let's take one example. Maybe no, actually this network is some redundant network, so may not be much useful for me to explain. But let me take one example. Suppose that you are having some number of IP addresses. Maybe there is one block which is, let's suppose, anything. Okay, so earlier it was okay. Let me take anything. 192.2. Let's take, okay, for example only. Let's for the sake of example, let's take this is 0, 1, 0. Okay, or something, right? And this is, there is one. Okay, suppose that these are the two networks. This is slash, let's suppose this is slash maybe 10, and this is also slash 10. Can you combine these two networks? Let's just see if we can combine these two networks. If you combine these two networks, what will the answer? 192.0, right? Because nothing is common, right? After it, dot 0 dot 0 slash 8. So how many how many IP addresses you had earlier? Earlier you had 2 power 22, and this is also having 2 power 22. So before aggregation, right? So before aggregation, you had the IP addresses, something like this. After aggregation, can anyone tell me? Once you aggregated all of this, then it will be 2 power 24. So which is nothing but 2 power 23 plus 2 power 23. Actually, this 23, if I rewrite it again, 2 power 22 plus 2 power 22 plus 2 power 23. So basically, there are 2 power 23 other networks that I'm having, right? 2 power 23 other networks. So what does this mean? Can anyone tell me? See, earlier I had these two networks. Now a routing, okay, a router which is saying that, okay, if next hop is common, see, next hop should be common. Okay, so here if the next hop or the interface, or this is also called next hop, if the next hop is common, which is m naught, then in that case what you will do, if the next hop is common, then you can aggregate. Okay, if otherwise you cannot aggregate. Obviously, if next hop is itself is not common, which means here for the r1, okay, for the r1, tell me if the next hop is common. Next hop is different, right? Then you cannot obviously aggregate. If that is going to different interface, then there is no point of aggregation. I mean, you cannot even do it, right? If the next hop is common, then you can actually compress those, right? Now let's just check here what is happening. Suppose the next hop is common and everything is common, then you can combine these two, and then after combination you are getting many IP addresses, but before combination you were not getting those IP addresses. So is there anything wrong I did, or something something is I mean, not correct? What do you think? So basically, there was a router. Okay, let me explain what I did. There was a router, okay, that was having these two entries. Okay, let's suppose R1, that is connected to some interface. Let's suppose this is R, and that is basically connected to this network and this network, these two networks. But with respect to this router, right? So this is connected to this network and this network. But with respect to this router, this is just M node. So these two networks, with respect to this router, this is 192, this one first network, and the second network, whatever it is. Okay, with respect to this router, these two networks both are basically just going to M node. So can I just combine or not? This is the first network. This is the second network. But if I'm combining, then I'm getting more IP addresses. And what does this even mean? Suppose these are the two networks that I have. So here earlier this R1 was maintaining two entries, right? Was maintaining two entries, maybe three. One is default one. Then I want to compress this to just two entries. These two entries, can I compress? Yes, I can compress. But what is wrong I'm doing? I mean, I'm increasing IP address, and what does it even mean? So here, see, if you're combining, then I mean, there is nothing wrong in this. I mean, you can definitely do it and everything is correct. But what does it mean to have an increasing number of IP addresses there? So whatever is the extra IP addresses that I have, see, it covers a huge range. It covers a range, which is basically it covers a range. Let me go to the next page and let me write the range of every network. Okay. So the range of first network and the range of second network is smaller than the aggregated network. So this aggregated networks covers a huge range, which is basically from 192.0.0.0, right? This is the first address here, and 192.255.255.255, something like this, right? This is the last address here, right? Now in between, it covers a network. This covers this whole network, which is in between. This covers all the IP addresses of 192 dot. I mean, it is all zeros, so it is 0, 1, and all you can change, right? And this is 1, 1, 190. This is just one of the network that I have, network 1, 0, 1. You can change 192.11. All you can change. This is just one of the network, right? But it is also having 0, 0, 0, 0, or everything, right? It is having, basically you can divide this into four. You can say you are dividing this into four parts. One is basically 0, 1, like one is 0, 0, subnet is 0, 0, subnet is 0, 1, subnet is 1, 0, subnet is 1, 1. And you are basically, actually you are just having this, right? This one and this one. So there are few things. I mean, these two networks, which are a huge network, these two networks are actually not there initially. But if I'm combining, I'm making these two networks like, okay, these are present. You're getting my point? Let me know if problem is clear to everyone. Ekta is saying, for privacy, multiple networks creating if we don't want to send data to it. No, this is not the privacy or something. This is not the subnetting. This is supernetting. Here at R1, this is about the redundancy. Okay. It is not about the privacy. It is about the redundancy. Basically, I am having a multiple entries. Why to have the multiple entries? If the next hop is same, okay. If the next hop is M0, then can I just not say that, okay, let me just maintain one of the entry, maybe 192. Okay. If it is starting with 192, let's just send to M0. It is just about the redundancy. Supernet is always about the redundancy. Okay. So if I'm combining, basically, if I do have, let's suppose I do have four networks. Okay. Suppose I do have four networks, then there will be nothing extra. Suppose I do have four such networks. Okay. Suppose I had to combine these four networks. Suppose these are the four networks that I have. Then I will say, okay, this 190 till 192, it is common. Okay, till 192. So I will convert that to 192.0.0.0/8. And in fact, these four networks are contiguous. Contiguous in the sense it is 0, 0. Okay, /10 is 0, 0. This is one of the subnet. This is another. I mean, subnet in the sense it is one of the network 0, 1. Then okay, there should be somewhere 1, 0. It is 1, 0, 0, 0, 1, 0, 0, 1, and 1, 1. Everything is there, right? So these are the four subnets that I have. I can easily combine. These are the continuous subnets, which means whatever it is covering. Okay, it is covering 2 power 24 IPs. And combinedly, this is 2 power 22, this is 2 power 22. Combinedly, these all are having 2 power 24. I mean, there is nothing extra IP I'm covering. Okay, this is 2 power 24 earlier. Before aggregation, 2 power 24. And after aggregation, 2 power 24. So I'm not covering any extra IP. here in this case, if the networks are contiguous and everything is very nice and so on, right? So I do not have any problem. But if the networks are not contiguous or not contiguous is okay. I mean, continuous is not even much concern. Let's suppose I have 0 0 and 0 1, even if it is contiguous, but if you combine, then you will be combining in /8. Okay, let's suppose if I have yeah, 0 1 and 1 0, I have these two networks. If you have to combine these two networks, then you have to combine in /8 only, because it is differing at the first bit itself. You're getting my point? If you are having two networks, 192.2.01 and something /10, 192.10 something something something, and then /10. Even though these two are contiguous networks, which means like after 01 there should be 10 only, right? In the subnet ID. Even though these two are contiguous network, then also if you combine these two, you will be combining in 192.0.0.0, and then it will be a bigger network, right? So the thing is, there is only one point that I want to convey, that can we cover okay, this is my question. I mean, earlier I had, let's suppose, some IP addresses which is just 2 power 22 plus 2 power 22, but after combination I have many IP addresses, right? 2 power 24. So I'm actually covering more IP addresses than I intended to cover. So can I do this? This is my question. Yes, there is no problem in covering extra IP. Okay, so there is no problem at all in covering extra IP. But suppose there is some IP that is something like this. Okay, 192. So here it is 0 1 and 1 1, and it is covering many networks, which is in fact 0 0. Suppose there is one IP which is, let's suppose, 1 0. Okay, it is starting with 1 0, and okay, let me tell you that what I'm going to do. So let me tell you that what is the current scenario. Current scenario is this R1 is connected to one router, and this is actually connected to two networks, right? One is 192.10 in the subnet. I mean, you don't consider as a subnet, but yeah, this is just a network /10. This is 192.11/10. Okay, these are the two networks that this R is connected to. But with respect to this R1, or with respect to this R1, this is just M0. So I'm just saying, so instead of these two entries, can you just have one entry which is 190.0.0.0/8? Then answer is yes. But what if I get a packet at R1 which is intended to neither this or not this, maybe this. Okay, let's just take a simple example first. Suppose it is intended to this network. Okay, anything here. Okay, 101, anything here. Then R1 will send to M0, definitely, right? Is this okay to everyone? So if it is belonging to, see, this is 10, and then R1 will send to this one, and let's suppose this is M1, M2, then R will send to M1. And suppose if it is 11, then R1 will send to M0, okay, and then R will send to, this is M2, R will send to M2. That is fine to everyone, right? Let me know if there is any doubt. Okay. Is this fine to everyone? So now suppose there is a packet that is coming to this R1, which is, let's suppose, maybe 01. Okay, suppose something like this. Then in this case, what's going to happen? Yes, it will go to default, right? I mean, R1 doesn't know. Earlier also R1 was not knowing. Now also R1 doesn't know. If it is an extra IP, earlier also, whatever I was doing, I will do the same thing. Earlier also R1 was sending, R1 must be sending to the default one, right? Now also R1 will send to the default one. Okay. But is it actually going to the default? That's the problem. See, this is 01. Since it is extra IP, right? Since it is extra IP, then like R1 will think that actually the whole of this should be here at R, right? So basically, earlier R1 was not, earlier also R1 was not knowing that what to do with that. Then earlier R1 was sending that to default one. Everyone agree? Earlier R1 was sending it to default one. Now R1 will say that now I know. Okay, now R1 will say that now I know. Actually, R1 was not knowing earlier, but now R1 will say that now I know. Then R1 will send to M0, but the decision is now at R. R will say that okay, I now know that should go to the default one. Something like this, right? So R will now send to the default, or whatever interface default means in case of R. I mean, these two default could be different, obviously, but in this case, the R1 will say R will send to the default one. Actually, if you're combining something like this, then those generally, okay, generally those extra IPs are not allocated. Okay, generally those extra IP is not allocated. And then earlier R1 was making the decision, now R will make the decision. That's the only difference. Yeah, if it is a loop, then after maybe 5 or 6 iterations, like after the TTL expire, it will be dropped, right? So earlier R1 was making the decision, now R will make the decision. So you can cover the extra IP, there is no problem. And in fact, in the book Tenenbaum that is written, okay. So in the book Tenenbaum also it is written that you can cover the extra IPs, there is no problem. So this is one of the misconception that students think that, okay, there should be DGULI 2 or something like that. Do anyone knows those rules? Like there were some popular non-standard rules. Okay. I mean, actually, I have not found those rules anywhere. So that's why I'm calling those non-standard rules. So, I mean, there are some Supernetting rules or something like this, right? I mean, there should be DGULI 4 or something like this. So I have tried my best, but I have not found anywhere. In fact, I found the counter examples of that rule. Okay. And no textbook was mentioning that there should be some rule or something. So you can definitely cover the extra IPs. Okay, so there is no problem. Only one thing that you need to remember in the supernetting is that jahan tak bhi common hai, take that common. Everything else just make zero. That's the only thing you need to know at the supernetting. Okay. Now let's just see more interesting cases in the supernetting. I mean, if you are doing the router aggregation, let's just understand this more carefully. And then there was a gate question. Okay, gate. In fact, the this year gate 2022 question only. We will be solving these questions based on the supernetting. And there are some other interesting questions that we have. Right. So let's just first cover more cases that in the supernetting we have. So let's just go to very beginning that what we were doing. We were basically saying that till whatever point it is common, we will take that common, everything is zero. So that's the only thing that we need to do in the supernetting. But let's just see more cases also. So suppose that there is one router R1, there is one router R2. These are connected like this. Now, okay. Now suppose that these are the networks, and I think we did this right. So here you will be combining all of this till 7 because till this point it is common. Now suppose one of the network in between is missing. Let's suppose this 128 was missing here. Will it be any problem to me if this 128 was missing? If this network was missing here, this third network, will it have any problem for the supernetting? Tell me. I'm saying, let's suppose this 128 is not there. I just have these three networks. Okay. This 128, some one of the network is not there. Then do I have any problem with the supernetting? So what I'm saying is this. See, suppose you are basically You're combining these, right? Okay. So was it okay? There is some problem with the mic, I think. Okay, I think there is a problem with the mic. Now, is it okay? Okay, I will check the problem later. But yeah, now if that is okay, then we can continue. Okay. So I'm saying that suppose that one of the network is not there. Maybe let's suppose this network is not there, right? Then can I still aggregate all of them? Yes, right? So you can always aggregate. There is no problem. Now, what will be a problem like generally if this is not contiguous and if it is covering the extra IP, then generally I'm saying those extra IPs are unallocated. Okay. If it is covering the extra IPs, then those extra IPs are unallocated generally. So if it is, let's suppose there is no IP address that belongs to this network, or this network does not even exist, then you can combine. If it exists, then probably you need to have one more entry. That I am going to show you. That what do I mean? Okay. So let's just see this. Suppose. So this is currently the scenario is this. You are going to combine this, and then you are going to say that okay, the default like one of the entry for this is this, right? This /24. Now suppose if one of the organization in the previous figure is not geographically close to the other three, which means let's suppose this is moving to some other location, okay, which is not connected to R1 or which is not connected to this M0 interface, which means that here, if I talk about this, then suppose this organization, this 192, okay, organization 4 has moved to here, which is basically not related to, let's suppose that which is not connected to this R1 anymore, which means not even connected to anywhere here or and then to here, which means this router R2, with respect to R2, it has moved. So R2 was earlier sending all the packet to M0, but now it has to make a call, whether it is either of these three or this is this fourth one, right? See, R2 routing table is earlier was saying something like this. It was this, right? This one, which is saying that by like if it is 24, then you can send all of them to this M0. But if you are moving, you have one of the organization here, then R2 will say that okay, you can still supernet, okay, you can still supernet. And since the fourth one is not there, that's okay. You can have one of the entry as M0. See, you can still supernet, but you will be having one more entry. And you will say the one more entry will be this one, which will say M1. So in this case, there will be two entries. One entry is having is basically representing these three networks, and another entry is representing the fourth one. Although this first entry is a very big entry, which actually covers, right? If mathematically it actually covers the fourth one also. But we are going to maintain one more entry for the fourth one. And it will not be a problem because of longest match. If something is coming to R2, if it is matching to both of them, see, if some address, let me show you. Okay, so suppose this is the routing table entry for R1 and this is for R2. So suppose there's some packet that is coming to R2 is something like this, which is basically belonging to this one, which is 140.24.7.195. Okay, suppose, which belongs to this one. Okay, now this R2 will say that okay, it is actually matching with this one. Actually, it belongs to this one, so it will match with this one. It will also match with this one because this is actually very big network, which actually covers this mathematically it actually covers the organization 4 also. So this IP address is matching with both of them, but I will send to which one? M1 or M0? Even though it is matching to both, I will send to M1, right? Because M1 is a smaller network, which is more specific. So this M0 is basically mathematically it is covering this one also. It is covering the range from 140.24.7.192/26. Mathematically it is covering this range, but still I will send to M1 because M1 is more specific. It is the longest match. It's a smaller network. So the larger the match is, the smaller the network is, right? So I will send to the smaller network because that smaller is more specific. In the bigger one, maybe I have covered the more extra IPs. So if something is moving geographically or physically to some other location, then also I can aggregate. It's just that I just need to maintain one more entry for that. Okay, I will be maintaining the multiple entries. See, suppose that I'm sending a packet from New York to London. Then I can see these this I have taken from Tenenbaum. I think these IP addresses are not following any rule, which means like any of the rule that that you have those rules that that some misconception is there that this should be contiguous or something, right? So this is not following any of the rule that you have. But still, I mean, you can anytime segregate. So you can like aggregate all of these networks, and it will say that okay, if the IP address is starting from 192.24. Maybe you can be very specific. Okay, 192.24. Something will be there. Let me go to this one. So now if you aggregate all of this, it will be 192.24.0.0/19. Okay, till 19 it is common. Now can you aggregate? Yes, you can aggregate. Are they contiguous or some are they following some rule? No, they are not following any rule or something, right? So this is a standard example that I've taken from Tenenbaum or maybe Cross, one of this. Okay, it is not from Frozen, I'm sure, but it is either from Tenenbaum or Cross. So I have taken this example from the standard textbook, and there is no need to follow any rule or something. Although there are no contiguous IP addresses or something, still you can aggregate. Now let's just check how many extra IPs I'm covering. Okay, let's just check just for the sake of curiosity. I'm just interested in checking how many extra IPs I'm covering. So this example, as I'm saying, I've taken from the Tenenbaum, and now in this example, I just want to check that before aggregation, how many IP addresses I was having, and after aggregation, how many IP addresses I was having. So before, how many IP addresses I'm having? This is 2 power 21. It means 32 minus 21 will be 11, right? Plus 2 power 12 plus 2 power 10. So before segregation, aggregation, I'm having this. After aggregation, I'm having 19. 19 means 2 power 32, which means 20, 30. Right? So I'm having after aggregation, I'm having this. Let me just rewrite this 2 power 13 as 2 power 12 plus 2 power 12. And let me just again rewrite this 2 power 12 as maybe 2 power 12 plus 2 power 11 plus 2 power 11. And let me probably again rewrite this one of the, okay, this one of the 2 power 11 is 2 power 10. So how many extra IPs I'm having? 2 power 10 extra IPs I'm covering, right? That's okay. You can cover extra IPs. That's not a problem. I mean, here I'm covering 2 power 10 extra IPs. But suppose that those IPs that I'm covering, suppose physically they actually get allocated to somewhere here, then what I will do? Okay, so I'm covering maybe 0, 1, 0. I need to check what are the extra IPs I'm covering. But suppose that physically I'm having that extra IP that I'm covering, this 2 power 10, that one of the network for this 2 power 10 is here physically. In future, let's suppose I allocate it. Then what I will do? I will just maintain one more entry, right? I will just maintain one more entry to this routing table. Currently, it's just one entry, which is 192.24.0.0/19. And in future, if which is saying M0, in future, if I allocate this 2 power 10 block to some IP address which is actually physically here, then I will maintain one more entry. Let me know if that is okay to everyone. And that obviously that entry, whatever entry I'm having, that will be having longer prefix, right? Maybe maybe something like 22, because it is just 2 power 10 block of 2 power 10. Maybe something like this. That will be having longer prefix. So anyway, like it will match with the longer one. So in future, if I allocate, see, I'm currently covering the extra IPs, but in future, if I allocate those extra IPs, okay, to somewhere which is physically somewhere here and there, then I will just maintain one more entry. So just that I will just maintain one more entry. That's the only catch here. Let me know if that is fine to everyone. No, I will let's suppose in future, if I have some block of addresses here, this 2 power 10, which currently I'm covering extra, which is unallocated. If I'm having that block of address here, then if some packet is coming to this New York, okay, some packet is coming to this New York, then if that belongs to this, then it will send to this interface. If that belongs to one of this, then it will send to M node. That's all. Right. So currently I'm having just one aggregate prefix, which is this one. Okay. Yeah. So that is there in the book. But suppose let's suppose that here, if I'm having in future, that's all. Right. I just need to maintain one more entry. So I hope you understood that we can cover the extra IPs. That's what I want to convey. That we can actually cover the extra IPs. Okay. There is no problem in covering the extra IPs. Where is that? Yeah. Can we cover extra IP? Then yeah, there is no problem in covering extra IPs. We can cover. And if in future those extra IP that I'm covering, if I allocate that to somewhere else, then that is okay. Otherwise, not if not even in future. Let's suppose here also, if I knows, okay, if I know that okay, this extra IP that I'm covering, see, in this case, I know that I'm covering the extra IP. See, this particular entry, isn't it covering the extra IP? This is covering the complete set of organization 4 IPs. If I know that okay, I'm covering the extra IP and those extra IPs are actually located physically here, so I will maintain 2 entries right away. If I do not know, or I mean, if they are currently unallocated in future, if you are going to allocate, then I will at that time I will maintain, right? Okay. So now let's solve some questions. Let's solve this question. Just a second. So what they are saying, they want to aggregate few of the entries. So what is the first thing for the aggregation? The next hop should be same. Okay. If the next hop itself is not same, okay, then obviously you cannot aggregate. Suppose that in this case, can you aggregate at the router London? Obviously no, right? Because here the next hop are different. For these 3 entries, whatever the London 3 entries are there, the next hops are different. If next hops are different, then there is no point in aggregation. I mean, you cannot even aggregate. If next hop are same, then only you can think of aggregation, right? Okay. So they're saying perform the forwarding table aggregation. We need to perform the aggregation on the following IP forwarding table and write down the final table content after all possible aggregations have been performed. Note that you may or may not receive the partial credit. Okay. So they want to perform the aggregation, all the aggregation that are possible here on this table. Let's just check. So tell me, can you aggregate these two? Or maybe let's suppose these two. Can you aggregate these two? Can you even think of aggregating these two? Tell me. No, right? Why? Because next hop itself is different. If it is R1 and it is R3, how you can aggregate? So next hop, that's the first criteria. That's very obvious, right? Next hop has to be same. Maybe you can aggregate these two and these 3, right? So let's just see if you can aggregate these 3. Yeah, this is, I mean, you can aggregate maybe. Let me see the answer. 1 and 6, they are saying 1 and 6 can be aggregated. Okay. Yeah, this is quite interesting question. Let's just check. See, this is saying till 24 it is same, right? Till 24 it is same. It is saying till how much it is same? I think this is 7. 7 means 3 ones. 3 1 means 5. So 16 plus 5, 22. I think this is 22. Okay. This is 24. This is 17. This is 8. This is 22. This is 16. Okay. Now what I want to check that what we can aggregate. That's very, very nice question. Now let's just do this question a bit carefully. Okay, first tell me, can you aggregate one, whatever is R1, maybe 1, 3 and 6. Can you aggregate this 1, 3 and 6? Sorry, 1, 5 and 6. Since the next hop is R1, then why not, right? Let me know if you are getting or not. So we can definitely aggregate this 1, 5 and 6 since the next hop is common. But there might be some problem in aggregation. Can anyone guess what could be the problem? I might cover the extra IPs, right? If I aggregate, I might cover the extra IPs, and those extra IPs, like covering the extra IP is not a problem. But those extra IPs are actually should not be allocated. Those extra IPs should not be already here. So let's just see if I aggregate, then what's going to happen. So one is 128.42.222.3, right? And then, okay, please convert this 222 and 216. Okay, this 222 and 216 in the binary and let me know quickly. So this is A. Okay, 222 is 110, then 4 times 1 and 0, right? Okay, and then 216 is this right? You're writing, so I'm just believing you. 216 is this one, right? 1101 1000. Okay. So if you just aggregate this A, this 1, and then this is 5, this is 6. So what is 5? 5 is 128.42.127, which is actually 1. Sorry, which is 0 and all ones. Okay, dot 3. And then here you have 128.42.216, which is 1101 1000.4. Okay, so here the mask is 24, which means till this it is fixed. Here the mask is 22. Okay, last 2 bits are not fixed. Here the mask is 22. Here the mask is 22. Okay, let's just see that what is common. These two are common, right? And then just a second. So this is 1101 110. This is 0, all ones. This is 1101 1, all 0. So they are saying till now everything was common, which is 128.42. Now they are not common after this point, right? They are not common after this point. Yeah, they are not common after this point. Now, yeah, that is okay. They are not common. But can you still aggregate? See, you can see that this in 1 and 6, there are too many of the things are common, right? I mean, till this point, maybe it is common. So you can definitely maybe like you can aggregate this 1 and 6. So okay, let me just tell you if there is any problem by aggregating this 1 and 6 only. So let me just write the 1 and 6 only. So this is 1 and 6. Now 1 and 6 is saying it is common till this point, I think, right? Till this point. And in this one, what was the mask? Mask is 24. Okay, so let me write the network ID only. This is 0 basically. So 1 is here the 0 is fixed, right? This is in the 6, what is the mask? 22. Sorry, it was mask 24. So everything is fixed here. It is 22. Okay, so you can definitely merge these, but obviously you are covering the extra IPs. let me go to the next page. Probably let me explain step by step. See, one IP address, or let me just check with 1 and 6. Okay, can you merge these two? If you are going to merge, are you covering the extra IP? If you are covering the extra IP, then will it be a problem? So we need to check very carefully. Okay, so this is 128.42. This is also 128.42 dot, it is this one. Okay, sorry, let me just write it, which is 1101.1110. It is 1101.1000, right? Dot something dot something. Okay, now the first is having 24 and the 6 is having 22 as a mask, which means that it is 24 means this is fixed. Okay, this is 22 means till this point it was fixed. So it could be 00, it could be 10, anything. So you can write anything here. I mean, this is just it can match with anything, right? So you can write even 10 or anything here. Okay, does not matter. So let's just check till what point it is matching. So I think it is matching till this point, right? Till this point only. Yeah. So let me use this color. So it is matching till this point. Let me know if that is okay to everyone. Is this okay? Now, how many extra IPs it is covering? So basically, it is fixed to be 110, and then it is fixed to be 0. So can you just guess, wild guess, any wild guess? See, it is 0. Then how many extra IPs you are covering? Then you are covering all, like this is 0, and then you are covering all set of IPs. That is like instead of 0, if it could be 1, then you are covering all set of IPs which are just 1 and 1. I mean, this bit, if it is 0, then yeah, then you are having this particular network, which means that the supernet that you are going to have. Okay, so whatever is the supernet that you are going to have, let's just call this supernet H1 plus 6, something like this. Okay, then or let me just write, okay, that is going to cover, obviously your 1 and 6 it is going to cover, but on the broader level I will say it is going to cover this 6. Okay, and then there is something that that you will divide, I mean that bit will be 1, and then if you divide that also into 4 parts, okay, this also into 4 parts, then it is just your one of that part, 1. Okay, it is basically covering these 3 extra nets. I mean, these, it is actually covering some more IPs. That's all I want to say. Is this okay to everyone? It is actually covering some extra IPs. Now we need to check whether those extra IPs, okay, which it is covering are already allocated or not. Let's just check it. So this is our routing table. Now I think 1 and 6 I have merged. I just need to check with other entries. So let's just check. Okay. So here, let's just check if it is basically having some, it is covering some other extra IPs which are actually allocated. See, this 1 and 6 are done. Okay. Now these set of IPs that 2 is having, is this covering the second set of IPs? 128.42.128.4, right? So select 17. 17 means this bit should be 1. No, this is a bigger network, right? This 128.4, which is just 17, it is a very big network. Okay, so it is not, I mean, this is very big network and it is not covering just this entire network. I need to check whether it is covering the entire network or not. It is not not covering the entire network. This itself is a very big network because it is just initially it is one, and then you're like this network is very big network. In this network itself, these networks can come, other networks can come. So it is not covering this one. What about this fifth one? It is /22 and this is 127.3. 127 means 0 all ones, right? Okay, so /22 means till this point everything is fixed. So now you can have 0 0 1 0 something like this. Is this covering this? See, it has to have 1 1 0 1 and it is basically something like this. So obviously there is no relation, right? There is no relation between the extra IPs I'm covering. That all the extra IPs that I'm covering are 1 1 0 1 and then 1, right? All the extra IPs that I'm covering are basically starting with starting something like this 1 1 0 1 and 1, but it is 0 or it is having all of this. So it is not having this 5. Let's just check if it is having this 6 dot 128.4.16. Okay, yeah. So if you have 16, which means you are just going to have this 128.42.0.0. So it is again very big network. See, this network is very big network, right? This is 128.42.0.0. So this is again very big network, right? So in this network itself, these networks can come. So that's why it is like whatever is the aggregation that I'm having, which is basically something like this. The aggregation that I'm having, it is 1 and all zeros, right? And then in the network ID, these are zeros and then 0. The aggregation is this. This is not covering this because it is a very big network. So if I combine these two, it should not be a problem. But let's just check, can I combine this fifth also? Okay. If I try to combine this fifth also, will it be a problem or not? I want to check this. So fifth one is /22. Is there any extra noise that is coming? I think it should come. Might be coming. Okay. So let's just check if I can combine this this fifth one, which is /20. Sorry, yeah, fifth one. So let's just check if fifth one I can combine with this also. Fifth one is 128.42.127, which is 0 1 1 1 1. Right, all the ones, right? So if I try to combine, then I will say till this point only. I will say till this point only I can have, right? Because till this point only things are matching. So if I try to combine this fifth, right, then in order to combine this fifth, I will say that my final answer is 128.42.0.0/16. So if I try to combine this fifth one, seems like I did too much, right? I'm covering too much of extra IPs. It seems like that. Let's just check if fifth one combining is a problem to me or not. So if I combine the fifth one, then my answer that I will be having is something like this. See, if I combine the fifth one also, I will be having 128.42.0.0/16. Is this okay to everyone? This is basically if I combine 1, 5, and 6. If I combine these three. So definitely I'm covering the extra IPs. Let's just check the IPs that I'm covering extra. Are there a problem to me? So I'm combining 1, 5, and 6. So the remaining is, I think that is matching is 2 and 7. So 2 is saying 128.42.128.4, right? So 128.42, obviously it is a problem to me. Can anyone tell me why? Because it is 1 here and then all zeros, so 17 bits are same. So basically it is containing, this is containing, entirely containing 2, right? It is containing, this particular network is entirely containing 2, and that should not be the case because 2 is routed to R2 and it is routed to R1. Okay. Just a second. Yeah, but it is having the longer mask, right? This is 17, which is having a longer mask. So I think till now it should not be a problem. And what about this? Yeah, for 2 should not be a problem because it is containing entirely 2, but that's okay. I mean, it is 17. So I can work with this. You're getting my point? See, if I combine 156, I'm getting this one, which is containing entirely 2, but it's okay to me because this is having the longer mask. So it anyway I will route to R2. If I still have this entry, then also I can write to R2. Okay. With respect to R3, let's just check with respect to with respect to this entry. If I combine this 1, 5, and 6, do I have any problem with this entry, which is 128.42.128.4/16? Yeah, this is a problem, right? This is actually /16 means 128.42.0.0/16. So if I combine, this is actually so they are saying it should go to R3. But if I combine all of this, then there will be a duplicate entry. Yeah, there will be a duplicate entry. So that's why obviously we cannot combine because these two entries will be duplicate. So if you combine 1, 6, there will not be a problem. But if you combine 1, 5, and 6, then you are going to get duplicate entry. Then if the packet is coming to some IP address, right, then it will get confused. So basically, like if you combine only 1 and 5, then whatever you are getting, oh sorry, only 1 and 6, I think, right? Yeah, only 1 and 6, then whatever you are getting is good. But if you add 5 also, then you are getting a very big network if you add 5 also, because 5 is not matching. I mean, 5 is basically just matching till this point. Then there will be a problem. Then this entry, the 7th entry, and the combined entry will be same. Okay, so see here, this is 1 is R1, right? Okay, so we are saying 1 and 6 can be aggregated, so the entries 3 and 4 also can be aggregated. So if you combine 1 and 6, then there will be R1. Yeah, so they are saying that if you combine 1 and 6, you will be getting something like this, which is okay, which is fine, because it is having whatever it is covering, it is basically not coinciding with some other networks. Maybe like I think I just made it complicated, but are you able to understand what I'm trying to say? So basically, once you combine, you can combine only based on the next hop, first of all. Okay, once you combine, you need to check whether it is a problem to someone else also. If it is not a problem, then only you can combine. So let's do one thing. Maybe we can do this question again tomorrow. Maybe I will think about some simpler explanation that I can do. Okay. And I will be adding some diagram so that I can have some simpler explanation to the same question. And then meanwhile, what you can do, you can also try before tomorrow, you can also try this question. Okay. This GATE 2022 question, which is also very good question. So basically here, there are some networks are given. Okay. And in the next page, I have written down the range of the networks. This is the network 1, this is the network 4, something like this. So there are some networks. This is subnet 1, subnet 2, and their network masks are also given. And then they're asking which of the following can be combined, correctly aggregated. Okay. I mean, if you aggregate, then they are saying that which of the following prefix in the CIDR notation can be collectively used to correctly aggregate. So this was the MSQ question. They are saying if you combine this table into some table, then apart from the default entry, something like this, apart from the default entry, what are all the entries are there? Maybe the entry A and maybe the option A and option C, which means this is the MSQ question. Multiple options will make one table. Okay. Yeah, you just try it. So multiple options will make one table. So that's the question I'm trying to explain is this, that here they are saying that collectively used to aggregate, which means that multiple options collectively is making just one table. So you just need to take the mark that which are the all options which are able to, you are able to make one table. So basically Basically on the next slide, I have slide where I'm just saying that okay, this is the network 1 range, this is the network 2 range, this is something like this. There are some extra IPs which are here, but these are the range of the networks. And just to give you a hint, I mean, what you can do for the options also, you just try to find out the range. That option is covering from this range to this range. Option B is covering from this range to this range. Option C is covering from this to this. Option D is covering from this to this. These are the networks. These are the options. So which option is best for that? Okay, you just try to solve this question. Okay, these are the two diagrams as a hint I have just attached. So we will solve these two questions, and probably this question again I will think about some simpler explanation with some diagrams and all. Maybe I will just type all the things so that it is easy to explain. Okay, so we will do in the next class. Okay. So thank you everyone. I will also upload some of the more videos that we are going to follow in the tomorrow's lecture apart from this particular topic. Okay. Thank you. Thank you so much.